So let's start with the rules to draw root locus. तो हमने क्या करना है, वी हैव टू सपोज कि हमारे पास जो पैरामीटर है वो ओपन लूप गेन पे है. हम ओपन लूप गेन को स्टार्ट करते हैं विद द गेन k. ठीक है. सो देयर आर सम प्रॉपर्टीज ऑफ रूट लोकी दैट आर यूज्ड टू ड्रॉ द रूट लोकस. नंबर 1, हमने उसको चेक करना है उसका k की वैल्यू क्या है, k की रेंज क्या है. ठीक है, कि उसके पॉइंट्स ऑफ रूट लोकस कहाँ कहाँ ड्रॉ हो सकते हैं. नंबर 2, द नंबर ऑफ ब्रांचेस ऑन द रूट लोकस, हमारे रूट लोकस पे नंबर ऑफ ब्रांचेस कितनी है. नंबर 3, सिमेट्री ऑफ द रूट लोकस, कि उसकी सिमेट्री क्या होगी. आपको मैंने इन द प्रीवियस कोर्स फ्रॉम इलेक्ट्रोमैग्नेटिक फील्ड थ्योरी हमने आपको सिमेट्री के बारे में बताया था काफी डिटेल में. नंबर 4 इज रूट लोकस ऑन द रियल एक्सिस, कि हमारा रूट लोकस क्या रियल एक्सिस पे बेस करता है कि क्या करता है. नंबर 5 एसिम्पटोट्स हमारे जो होंगे रूट लोकस के वो क्या होंगे. उसका ब्रेक अवे पॉइंट्स ऑन द रूट लोकस, ब्रेक अवे है कि जहाँ से हमारा रूट लोकस ड्रॉ होगा. पर डिपार्चर एंगल एंड अराइवल एंगल, ये हमारे पास डिपार्चर और अराइवल जो होगा उसके एंगल्स क्या बनेंगे. ऑन द पॉइंट 6 वी कैन हैव ब्रेक इन पॉइंट एज वेल. ठीक है. उसके बाद इंटरसेक्शन ऑफ द रूट लोकस विद द इमेजिनरी एक्सिस, इमेजिनरी एक्सिस पे हमारा इंटरसेक्शन क्या होगा रूट लोकस का. एंड नंबर 9, द सम ऑफ द रूट लोकस एंड द प्रोडक्ट ऑफ द रूट ऑफ द क्लोज्ड लूप कैरेक्टरिस्टिक इक्वेशन. ठीक है, वो क्या उसका होगा. So the 9 point we have to be clear. So let's start with the point number 1, where we say k is equals to 0 and k is equals to infinity points. तो हमारे पास इक्वेशन, हमने ऑलरेडी इक्वेशन एक ड्रॉ की हुई है. अगर आप इफ यू हैव लिसन द प्रीवियस लेक्चर्स वी नो द इक्वेशन. ठीक है, जो कि हमारी ये गिवन इक्वेशन है, इस इक्वेशन को हम यूज करते हुए हम वी विल फाइंड आउट. सो ठीक है, this is the root locus equation and that will be the magnitude equation. You know the how to find the magnitude. Okay, so k is equals to 0, s will be equals to pi. Okay, so root log start from the pose of g of s into h of s. root log जो हमारा ड्रॉ होगा वो हमेशा पोज से ही ड्रॉ होगा. ठीक है, this 0 is for 0 and the p represents the poles. Okay, and you know that the numerator and denominator and about the poles and zeros already. ठीक है, रूट लॉग की एंड एट द zeros of the g of s into h of s. स्टार्ट होगा हमारा जो होगा वो होगा पोल से और एंड होगा zeros पे. So root log key originates on the poles of g of s into h of s for k is equals to 0 and terminates on the zeros of g of s into h of s as k approaches to infinity. The second point was the number of branches on the root log key. Already we have the equation. What we need to do is the order of the characteristic equation is n as k varies from 0 to infinity, and n is a root changes or n is a n root log. So for a real physical system, the number of poles of g of s into h of s are more than 0, but n greater than n. So n is the root log key and at open loop zeros, finite zeros, and m is the root log key ends at open loop zeros, finite zeros. So we have n minus m, that root log key ends at n minus m infinite 0. So n minus m से हम फाइंड आउट करेंगे कि हमारे पास नंबर ऑफ ब्रांचेस कितनी है. ठीक है, then order system will have a n starting point and R will have n branches. तो हमारे पास n minus m, n हमारे पास क्या है, नंबर ऑफ रूट लॉग की n ओपन zeros. ठीक है, and m जो है, सॉरी ये है पोल्स और ये है zeros. ठीक है, so symmetry क्या हो सकती है. The RL are symmetrical with respect to the real axis of the S plane. The roots of characteristic equation are real and or complex conjugates. Therefore, we only need to draw the root locus on the up half S plane and on the real axis. The rest can be obtained by plotting its mirror image. So, the root locus on the real axis. On a given section of the real axis, root locus for k is greater than 0 are found in the section only if the root is the total number of poles and zeros of g of s into h of s to the right of the section is odd. For example, this one, if we have 0 z1 and pose p1, p2, p3, p4 and p5, so our root locus will be something like here. So pick a test point S1 on P2 and P3. तो हमने एक ऐसा point test किया जो कि जिसको हम S1 कहते हैं, in between P2 and P3, here somewhere here. We have the characteristic equation, the angle which is on here, here is equals to 180 degrees. So this will make an angle of 180 degrees between them. If you see, the angle will be here is 180 degrees. Sum of angles provided by every pair of complex conjugate poles are 60. You know that, right? From here to here is one of full 360. So the angle provided by all the poles and zeros on the right of S1 is 180 degrees here. So the angle provided by all the poles and zeros on the left of the S1 is 0. So this is the way we have to design our angles. Okay, we can see all the red lines showing that. Now, example, consider the following loop transfer function. हमारे पास एक ऐसा ट्रांसफर फंक्शन है जो कि हमें एक ट्रांसफर फंक्शन गिवन है, determine its root loci on the real axis. Okay, so हमारे पास pose हम डिनोट करेंगे रेड क्रॉस से and zeros हम शो करेंगे येलो सर्कल से, and if we have repeated poles we can draw it on this side. Okay, so but with this open transfer function we have to check how many zeros and how many poles we have in our S plane. So you can see they are 3 zeros, S plus 1, like 1 minus 1 and minus 4 and minus 6. We have 3 zeros, and we have 1 pole on S minus 2 and 1 pole on, and 2 repeated poles on 0 and 3, minus 3. On the right of minus 2 and minus 1, the number of real zeros and poles are 3, right? On the right of minus 6 to minus 4, the number of real zeros and poles are is equals to 7. Okay. Now let's go towards the asymptotes of root locis. We have the RL equation, and when n is not equals to m, there will be 2 into n minus m as asymptotes that describe the behavior of the root locus at s is equals to infinity. So if you look at the equation, after that we'll see the angles between the asymptotes and the real axis are I is equal to 0, 1, 2, up to n minus m minus 1, right? So we have the equation is phi a is equals to 2i plus 1 into 180 degrees over n minus 1. So the asymptotes intersect the real axis at by this equation. So example, consider the following root transfer function. Determine the asymptotes of its root locus. Let's see how many asymptotes we can get by having this transfer function. So if you see in this, we have 1, 2, and 3 poles, which is on 0, minus 1, and minus 5. But we have 1, 0 at minus 4, right? So n minus 1 is equals to 3 minus 1, which is 3 is a pole, minus 1, 0 is equals to 2. So asymptote intersect the real axis is at number of poles and the minus number of zeros divided by n minus 1. So we have 0 plus, we have minus 1, the poles, sum of poles, all the poles. We have 0 plus minus 1 plus minus 5 minus and 1, sum of all the poles, so we have minus 4. Divided by 3 minus 1 is equals to, so the number of asymptotes intersect the real axis at is at minus 1. So the angle between the asymptotes and the real axis are 2i plus 1 into 180 degrees over n minus 1 is I is equal to 0 or 1. So these are the formula that we are using for angles, and we have using for asymptotes, and we have the equation for our root locus. So here the angle will be 90 degrees or 270 degrees. Okay. So considering the following transfer function, again we have to determine the asymptotes of its root locus. Okay. So in this case, what we have here, we have 1, 2, and we have two poles here, which is complex poles. We have 0, pole at 0, we have pole at -4, and we have two complex conjugates on -1 plus j and -1 minus j. Right? We have 1, 0 here, which is -1. So n minus 1 is equals to 4. We have four poles, 1, 2, 3, and 4. -1 is equals to 3. Now, the asymptotes intersect the real axis at here. So it will be equals to number of all the poles. Sorry, uh, sum of all the poles. We have 0, we have -1 plus j, we have plus -1 minus j, and then plus -4, and then number of all sum of all the zeros. We have one zero, so we'll write it down -1. If we solve them, you'll see it's -5/3. So the angles between asymptotes and the real axis are 2i plus 1 into 180 degrees over n minus n. I will be equals to 0 and 1 and 2. So if we make it in a angle, we'll see in degrees that will be equals to 60 degrees, 180 degrees, and 300 degrees. If you draw this root locus, we'll have something like this: that -4, we have pole here, we have pole here, and we have two poles here, right? So the value will be -5/3. So we, the intersection points, the intersection asymptote point is on here, is -5/3. And then we have an angle. We have to check the angle. We have one angle here, the total angle. We have one angle here, and we have the one angle here. So we have all the three angles: 60 degrees. They both are 60 degrees, and we have 180 degrees, and we have 300 degrees. So breakaway and points on the root locus. The breakaway points on the root locus are determined by finding the roots of dk over ds is equal to 0, or d g of s into h of s is equal to 0. The breakaway point on the root locus corresponds to multi-order roots of the RL equation. So if we see this, we'll see कि हमारे पास break away points and break in points हमारे पास क्या हो सकते हैं, right? So we have an example to understand our the poles and zeros of g of s are shown in the following figure. Determine its root locus. We have poles and all the zeros here. So first of all, we have to find n minus m. So we have three branches starting from pole 0, -2, -3, and the ending of the finite zero, which is -1. Okay, and the two infinite zeros and the RL are symmetrical with respect to the real axis. Right here, we understand that. And then rule number 4, the intersection, which is -1 and 0, and -3 and -2 on the real axis are on the locus. Okay. So rule number 5, we have to do asymptotes. Asymptotes, we know that n minus m is equals to 2. तो हमारे पास ये हमारे पास equation है for finding asymptotes. We can find out asymptote which is equals to -2, and the angles, the angle is 90 degrees and 270 degrees. Now we have to draw the root locus. Root locus have breakaway points on the real axis within -3 and -2. So here it will be a breakaway point somewhere here, which is -2.47. So here we will be -2.47. So these will be our breakaway points. The points from breaking from here, from between the two poles, right? Like the example, we have an open loop transfer function, which is k over s into s plus 4 over into s k plus 4 s plus 20. The same procedure we have to do: rule number 1, rule number 2, 3, 4. So we have n is equals to 4 and m is equals to 0. We have no zeros here, as you can see, and we have 1, 2, and two other complex poles we have here. N is equals to 4. And then the rule locus are symmetrical with respect to the real axis. We have two We have four branches which start from pole 0, -4, and the two poles are -2 plus minus j4 and plus 2 -2 minus j4. The root locus ends at the infinite 0. The intersection -4 and 0 on the real axis is RL. As you can see, कि हमारे पास ये हमारी सिमेट्री बनेगी, ठीक है? We have two complex poles here and we have this pole here. So let's see rule number 5, which is हमारे पास asymptotes कितने हैं, ठीक है? तो हमारे पास we have 4 asymptotes as you can solve from the equation and हमारे number of poles and zeros के base पे, तो ये हमारे पास होंगे 0, 1, 2 and 3, ठीक है? और हमारे पास एंगल उसके बनेंगे 45 degree, 5 degree, 5 degree and 315 degrees, right? ये हमारे पास number of asymptotes are on this two, ठीक है? तो intersection point हमारे पास है -2 से हमने इसके ब्रेक इन और ब्रेक अवे पॉइंट्स को टाइम कर लिया, उसके बाद ब्रेक पॉइंट को हम इससे हम इसको फाइंड आउट कर लेंगे. So we will have 0 और ये हमारे पास -2 and -2 प्लस -j 2.45. तो हमारे पास इस तरह के ये 2 पॉइंट्स बन जाएंगे, ठीक है? So this will be our breakaway points on root locus, like these two. Number 7. Number 7 point कौन सा है? This is angle of departure and angle of arrival of the root locus. हमने ये सब कुछ ड्रॉ कर लिया, उसके करने के बाद हम देखेंगे कि हमारे पास जो एंगल्स हैं, डिपार्चर एंगल एंड अराइवल एंगल, वो कहाँ पे होंगे. So angle of departure or arrival of root locus at pole or zeros respectively of g of s into h of s denotes the angle of the tangent to the locus near the point. If you look at here, you will see कि हमारा poles और zeros के नजदीक the near what will be the our departure of angle, departure of arrival, sorry, angle of arrival and angle of departure, what would be, okay? So these two of them are our angle of arrival and angle of departure. Let's find out, we can find out this by this equation. We can find out the angle of departure and angle of arrival.
और स्क्रीन भी शो नहीं हो रही है.
So pick up a point on S1 that is close to P1. यहाँ पे कोई ऐसा पॉइंट हम पिक कर लेते हैं जो कि हमारा क्लोज टू है P1 के. Applying angle equation, we have this equation, angle equation. We will get the angle of departure through this equation, and we have which is this one. तो उसके बाद हम लोग ये हमारे पास होगी equation. Now we solve an example to consider the following transfer function, and we will find out when k varies with 0 to infinity. ठीक है, अब हम पूरा एक रूट लोकस को फाइंड आउट करने का मेथड, उसको हम क्वेश्चन सॉल्व करते हैं. तो ये हमारे पास हो गए 3 पोल्स हो गए इसमें हमारे पास, जो कि हमारे पास है -1 जो कि रिपीटेड पोल है, P3 पे है हमारे पास 1 है और 1 zeros है, ठीक है. So n minus m is equals to 2, 3 branches and 2 asymptotes. We can solve them by this. We can find the angle of departure. So this we have a two angle of departures, pi by 2 and 3 pi by 2. We have this root locus. Okay. The intersection of the root locus with the imaginary axis. Intersection of root locus with IM imaginary axis. We say IM axis. The characteristic equation have roots from the imaginary. Rawls criterion to obtain the value of the k when the system is marginally stable and the get maker from k. और दूसरा मेथड क्या है, हमारे पास एक फार्मूला है, सी इक्वल्स j मेकर अप्रोचेस टू 1 प्लस d of s into h of s equals to 0. So if we solve them, we can find out the intersection of RL with the imaginary axis. Let's see, and solve for method 1 and method 2. We have a loop transfer function k over n s into s plus 1 into s plus 2. So हमने क्या करना है, determine the intersection of the RL with imaginary axis. ठीक है, हमारे पास ये होगी इसकी कैरेक्टरिस्टिक इक्वेशन रॉ टेबुलेशन से हम लोग इसको सॉल्व करते हैं तो व्हाट वी हैव marginally stable k is equals to 6 and we equation will be 3x square plus 6 is equal to 0. So हमारे पास इसके जो x will be equals to plus 1 order root 2 that will be the intersection point. ठीक है. नंबर 2 अगर हमारे पास क्लोज लूप ट्रांसफर का कैरेक्टरिस्टिक इक्वेशन है राइट सो हम इसको इक्वेशन में पुट करके हम लोग फाइंड आउट कर सकते हैं हम इसके रियल एंड इमेजिनरी पार्ट